The power cable may occur in operation, such as single-phase ground, multi-phase short-circuit grounding, disconnection and flash envelope failure, cable head explosion, etc. Especially for the cable fault buried in the underground or in the cable trench, it is not easy to find out, and the power supply needs to find out the cable fault part as soon as possible, in order to deal with it as soon as possible. There are many methods for cable fault, and appropriate inspection methods should be selected according to the specific site conditions and cable fault nature. The following simulation cable fault detection as an example to explain the fault detection of power cable. The dangers of this work are: 1. Electric shock injury. 2. Falling objects hurt people. Safety measures include: 1. Install fences and hang signs. 2. Meastest and adequate discharge before contacting the cable. 3. Counter-end cable shall be supervised by special personnel. The safety tools used in this test are: insulating gloves and discharge rods. The instruments used in this test are: multimeter, Magyar and cable fault rangefinder. Before the test, check the appearance and air tightness of insulating gloves, and check the label, which is within the validity period. Check that the appearance and scalability of the discharge rod are good, and check that the label is within the validity period. Check whether the grounding wire is broken. Then wear insulating gloves and fully discharge the cable with a discharge rod. Step 1. To probe the wire core. 1. Short connect cable end to end and ground. 2. Self-test on the multimeter, qualified. 3. Conduct cable conductivity test. A, B phase, not through. A, C phase, through. B, C phase, no through. A to ground, conduction. B to ground, not through. C to ground, through. 4. The diagnosis was a broken fault in phase B. Step 2. To probe the main insulation. 1. First remove the cable at the short end. 2. Self-test, millimeter open infinity, short circuit is 0, normal. 3. Measure the insulation resistance. A is relative to the ground, and the measured A is infinite relative to the ground. B is relative to ground, and B is measured to be infinite relative to ground. C is relative to ground, and the measured C is 0. 4. After using the Eurometer measurement, the cable needs to be fully discharged. Retest the phase C with the multimeter, and the relative resistance value of the test result C is 7.5 ohm. 5. The diagnosis result is that phase C has low resistance grounding fault. Step 3. Failure positioning. 1. Measure the total length of the cable. Since phase A is an intact phase, measure phase A to measure the total length of the cable. Correct the range and wave velocity of the rangefinder. The wave velocity is 170 meters per microsecond. The measured total length of the cable is 339.1 meters, and the total length of the cable shall be temporarily stored. 2. Measure the fault distance. Measure the waveform diagram of phase B fault point. By comparing with the waveform diagram of the full length of the cable, it is measured that the distance between the fault point of phase B disconnection and the test end is 298.4 meters. The waveform diagram of phase C fault point is measured. By comparing with the waveform diagram of the full length of the cable, it is measured that the distance between phase C low resistance grounding fault point and the test end is 171.7 meters. 3. Complete the survey work and sort out the site. Work summary. The measurement results are: phase A is intact, phase B is a broken line fault, and the distance from the broken line fault point of phase B to the test end is 298.4 meters. Phase C is a low resistance grounding fault, and the distance between phase C low resistance grounding fault point and the test end is 171.7 meters.